Well, hello everyone. It's Martin Fair here from SLCan. Welcome and thanks for joining us today for the webinar. I'm very pleased to introduce Marcel Dion for our webinar today on steam or dry heat sterilization, a question of efficiency. Marcel is the Director of Marketing for Washing and Steam Sterilization Systems in the Life Sciences Division of Steris Corporation. For the past 17 years, he's been responsible for developing innovative, efficient cleaning systems for critical drug manufacturing parts. He's also responsible for Steris steam sterilization product lines that are used in both research and pharmaceutical applications. I'd ask that throughout the presentation, if anyone has any questions they would like to get answered, please type them into the dialog box, and after Marcel has completed his presentation, we will certainly go through them all. And without further ado, I'll turn it over to you, Marcel.
Hey, thank you. Thanks, appreciate that. And good morning or good afternoon, everybody. My company supplies equipment for laboratories in the pharmaceutical industry, and it's very much focused on decontamination equipment as well as services and things like that. So we do get this question on a regular basis. You know, a lot of our customers are facing that dilemma, or that they're just wondering. They don't know about which of those two processes they should look at for their specific application. So that's why we came up with the idea of developing that webinar. We also wrote an article on that same topic, but the webinar is really meant to give you some tools and some ideas to consider, some areas to look at when you are considering to procure a sterilizer or a mechanism to sterilize in your facility. So as most of you probably know, there are many different methods available for sterilization on the market today. In addition to steam and dry heat, there's vapor-based solutions, gas solutions, is infrared. There's chemical methods like prussic acid. There's microwaves and so on and so on. So the list goes on and on. But for the sake of this presentation, we will focus on the two main methods, which are steam and dry heat. So that's what we're going to talk about today. So the main objectives for the webinar is to go through the various the advantages and the disadvantages of both methods, which hopefully in the end will help you make the right decision based on what you're trying to achieve in your facility. Before we can really dig into the selection process, it's very important to first understand how the processes work, okay? Because they don't work the same way. So that's why the first part of the presentation will be focused on understanding those two processes and how they work, how their kill mode are different, and so on. And then we'll talk more about the applications, or the typical applications for both methods. The third point will be around cost of ownership, or I should say total cost of ownership. And we'll go through the entire life cycle for equipment such as those two pieces, and then we'll see. We'll try to compare a little bit the total cost of ownership, and finally there will be a few considerations, additional considerations to talk about, and potentially there will be some time at the end for questions, and if not, then you will be invited to submit your questions by email, and then I will respond as soon as it will be possible for me. So these are the key topics for today. Okay. So first, let's see how the steam process works. So that's not going to be a very intensive course here on steam sterilization, but just an overview of how that process works. It is a process that uses moist heat, okay? So as opposed to dry heat. So that the term moist is very important, as you will see later. And it's a process that happens under pressure. It has proven over the years to be a very, very reliable and dependable process. And what makes it very efficient is the presence of the moisture, and it's that mixture that actually denatures the protein material and makes that this is what makes it so efficient and quick, I would say. All right. So the way it works is because it works under pressure. First of all, it requires a pressure vessel. A pressure vessel is a very sturdy, very strong chamber that is usually also enveloped in a jacket in which we can circulate water for cooling, or we can maintain steam to ensure that the sterilizer is always ready to process a load. So there, it's a very strong chamber, okay? And that pressure vessel is required to sustain or to withstand the increased pressure and the temperature that is required with saturated steam. The way it works is that steam is simply injected in the chamber, and at one point it condenses on the surfaces of the components that you're trying to sterilize, and it's when that condensation occurs that the energy, what we call the latent heat energy, is transferred to the product. It's a process that occurs in the range of 200 degrees Fahrenheit or 121 C. It can be higher, it can be lower, but as I would say, the majority of the applications are in that range of temperature, and it will occur at a pressure of anywhere between 15, 16 psi-G, which corresponds to 100 to 110 kilopascal. So for this to work, the equipment has to be able to withstand a combination of pressure, but also vacuum. The pressure pulses and vacuum pulses are used to, at the beginning of the cycle, to condition the load. When we say condition, that means prepares the load. It means removing the air from the load items so that the steam can penetrate and do its job. And the vacuum is used also at the beginning, again, to pull the air, but it's also used at the end to dry the load, because as we create vacuum, the boiling point goes down, and as the boiling point goes down, the water can more easily evaporate. And this is how we dry in a steam sterilizer, is by evaporating the condensate. So the pressure vessel typically has to be able to withstand not only the pressure pulses, but vacuum pulses, which can go as deep as 0.5 psi absolute psia, or 3.5 kilopascal, and the pressure can go up. In most industrial sterilizers, can go up to 32 psi for some specific applications. So that chart here shows how efficient that steam process is. What you see on the right is a typical log reduction curve for a given microbial population. And it shows how, for a temperature of 121 degrees C, in this case, how the population of microbes is reduced from 1 million to 1, okay? And you see everything is happening within 12 minutes. So that is a very fast process, and that's at 121 degrees C. We'll see later what may happen if we if we change the temperature. But for a given temperature, you see a 6 log reduction. Now, 1 log reduction corresponds to 90% reduction of the microbial population. So every time you reduce the population by 90%, that corresponds to 1 log. And and what you see here, the D value is the time that it takes to reduce that population by 1 log or by 90%. So the D value vary depending on the bacterial load, but a 2 minute is very typical for the majority of the typical stuff we need to sterilize. The impact on temperature is dramatic. One can see how simply by increasing the temperature from 121 degrees C to 132 degrees C, the time is reduced from 12 minutes to less than 1 minute. And if you look at going even higher, like 140 degrees C, then your time becomes seconds. At the opposite, if you lower the temperature, like 100 degrees C, then your minutes become hours. Okay, so it's pretty significant, the impact on time. So again, most application in life sciences will be the 121 degree range, and some healthcare because of the productivity requirements are using a lot the higher temperature to get some shorter cycle times. The other thing is in the healthcare environment, most instruments that are sterilized can easily withstand a higher temperature, which is not necessarily the case in life sciences when we're sterilizing plastic and other materials that cannot withstand the temperature. Okay, so the dry heat process is similar, but it's also quite different. The way this works is it's simply it's a simple chamber in which air is heated, and usually it's heated by electrical coils, and that air is recirculated in the chamber to ensure that the temperature is all the same throughout the chamber. But it's mostly the most important thing is that it happens at the atmospheric pressure. So there's no notion of pressure or vacuum in a dry heat sterilizer. Everything happens at the atmospheric pressure, which is an advantage, because as you will see a bit later. And when you look at the cycle itself, it's quite similar. Okay, that's where the two processes are somewhat similar, is in that there is always a preparation phase or a heat up phase in the steam sterilizer, with a conditioning phase that occurs just before the exposure phase, where the load is exposed to the right temperature for the right amount of time to achieve the required kill. And then that is usually followed by a cooling phase to make sure it is safe to handle the components after the process. In the steam sterilizer, it's a dry phase, but it's the same structure, if you want. Now, the big difference, in addition to the fact that it's occurring at atmospheric pressure, is the fact that to be efficient, the dry heat process has to be happens at a higher temperature. The very typical temperature is 300 degrees F or 150 degrees C. So that's a significant difference here, as you will see later, because some components may not be able to withstand such high temperature. So the way it works is first of all, the product is brought up to the temperature, to the sterilization temperature, which may take more or less time, depending on the load, how big the load is, and what material it's made of, and so on. And then that temperature is held at that level for the exposure time. And that time has to be sufficient, obviously, to kill all the organisms that are present. So the mechanism is, we're using convection to move the air to transmit the heat. We use conduction to pass the heat from one material to another. And we use radiation, if you want, like the sun, it's radiating heat. So all those mechanisms are used to transfer the energy. But it's a process that is significantly less efficient than the latent heat transfer that occurs when steam is condensed on a surface. So that's why when you look at the time on a dry heat sterilizer, the sterilization time is likely to be significantly longer. So the time you have when you look at a dry heat sterilizer, you have to allocate or take into consideration that there will be some time before the exposure to bring the temperature, to bring the product up to the right temperature. It's a little similar in a steam sterilizer when we're processing liquids, where the liquid temperature does not necessarily follow the temperature in the chamber. In the dry heat process, we cannot do liquids, but it will take a bit more time for the product to get up to the right temperature. So in other words, the temperature of the product may not be the same as the temperature in the chamber. So you have to take that time into consideration. We call this a lag time. Once it's at temperature, then it will remain there for the exposure time, and that will be followed by the cooling phase. So why is it not as efficient as steam? It's because it's the killing mode which is different. With dry heat, we're dealing with a kind of like oxidation or a burning process, whereas in the steam, it's a coagulation process, which is happening a lot more quickly and at lower temperature. So it's been proven, that the oxidation or that burning process is not as quick as the coagulation. As a matter of fact, if you look at data, which you can find in reference books like Perkins or Block, those they're not new research. Okay, 1980. These are references, Bibles, if you want, that were produced many years ago, showing differences between those two processes. And if you look at the relationship temperature time for dry heat, you can see how different the time is. If you remember, we were talking about 12 minutes at 121 degrees C. Here, if you look at 121 degrees C with dry heat, the exposure time will have to be many, many hours. In fact, to have a reasonable exposure time, you have to be in a significantly higher range of temperature, like over 300 degrees Fahrenheit. So that is right there the big difference between the two processes. So it's certainly something to carefully evaluate when going through a selection process. Okay, so I will not say that we are now experts in both processes, but I think we understand enough about the basis to start talking about what are the typical applications. for both processes. And clearly, the very first thing that one need to look at is the ability for the items to be sterilized to withstand those three key parameters. Okay, so the temperature, the pressure, and I would say also the vacuum. The combination of both. At least the pressure for sure, and moisture. So that's the first thing to look at. If an item can accept that combination of heat and moisture and pressure and vacuum, so forth, the steam process is by far the most universally accepted method used globally, whether it's in research or pharma applications. It remains the most commonly used process. Why? Because it has that capability of penetrating dense materials. It can be used to sterilize wrapped items, containers. You can even do tubing if you're using vacuum. So it's a very versatile process, and consequently, it's used a lot. Like in the pharma applications, it's going to be used for sterilizing components that are used in the manufacturing process of drugs. So all the manufacturing equipment will have parts that are in contact with the drugs. Well, those parts have to be cleaned and sterilized. And then, so the steam process is used a lot for that kind of application. It's also used in that same in the same industry for terminal sterilization of drug products, drug containers, and so on. It's of course also used in laboratories for pretty much all applications. One particularity of steam is that it can be used for sterilizing liquids, which is not something possible with dry heat. So, and it really doesn't matter the viscosity or the type of containers. It is a nice, it is a very important capability because many labs do require to process liquids somehow. So the dry heat is not, well, let me go back here and explain a little bit why we can do, how we can do liquid, because if we, as you know, the boiling point for liquids, for many liquids, is around 100 degrees Celsius, right? So if we bring the temperature to 121 degrees C, how come the liquids don't boil? Well, it's because of the pressure. As the pressure is increased in the chamber, so is the boiling point. So as you raise the pressure in the chamber, and the combination, temperature and pressure, the boiling point goes up, and that's how you can bring the liquid to sterilization temperature without having that liquid to boil over. In a dry heat process, you would not be able to do that, only because as soon as you reach 100 degrees C, again, for most liquids, it would start boiling over, and it's not pretty when that happens. So, as we mentioned earlier, the dry heat process is a slower process, and it is used in both pharma and research markets, but it's mostly used for materials that actually could be damaged by moisture or that cannot be penetrated by steam. So we see this kind of equipment used in pharmaceutical environments to sterilize powders, as an example. Okay, so trying to sterilize powder with steam is usually not working very well. You can also use dry heat to sterilize oils and some petroleum-based products, and it's also used in research for hard goods, stainless steel components, animal cages in lab animal research facilities. It's used in, of course, in healthcare environments, sometimes for surgical instruments, scissors and blades and things like that. So as long as, of course, those items can withstand the higher temperature. But again, it's like your plan B. Okay, like most applications will privilege the steam because of its efficiency and the cycle time. But it can be used as well for those other applications I just mentioned. One very typical application for dry heat will be depyrogenation of glassware used in lab or in particularly in the lab in the pharma industry. So I'm not going to explain here what pyrogens are, but I could just summarize by saying that they include endotoxins and exotoxins, and that to get rid of those pyrogens, you typically have to use dry heat in the range of 250 degrees Celsius for something like 30 minutes, or lower temperature, 200 degrees C, but then for longer time, like 60 degrees for 60 minutes, I mean. So depyrogenation is clearly it's not something we can do in a steam sterilizer. It has to be done in a dry heat oven. So as mentioned earlier, we cannot use dry heat for liquids because of the boiling point, which is in the range of 100 degrees C. So that's one, I would say, one disadvantage of that process. Now, it can be used in some laboratories just for melting some solutions like agar or other I don't know, grease or other material that needs to be melted. So as long as it's below 100 degrees C, it can be used also to warm up things or items. All right. So we talked about the applications. Now we can look a little bit more at cost. And when we talk about cost, we'll look at the total cost of ownership, starting at the investment all the way through the operation and maintenance of the equipment. So the dry heat sterilizer, if you compare with a similar steam sterilizer, same chamber size, all right, well, it's very likely that the dry heat sterilizer will be less expensive. It's generally less expensive. Why? Because it's not so heavy. It doesn't have a pressure vessel with a jacket. And you typically, so in general, it's less complicated than a steam sterilizer. It can be mounted on the floor. In some cases, you may need a little pit to install it to make sure the floor of the chamber is flush with the floor in the room. But it's not going to be as deep as the pit that you would need for a steam sterilizer. So, and in many cases, you just don't need a pit at all with the dry heat. So that is a nice advantage here, and you don't have so many utilities to connect. You don't have to connect steam and water and so on and so on. So it's easier to install and connect. Did I skip? Oh, I wanted to talk a little bit more about the installation costs. So the installation itself should also be less, let's say, less expensive, only because you don't have so many things to consider as opposed to the steam sterilizer. A there's something else I wanted to say here. But again, this is all assuming that the same chamber size can do the job of the steam sterilizer. And we'll talk more about productivity in a minute here, but what I'm referring to here is when we're comparing same size, the same piece of equipment, same chamber size. Now, when you look at the operation cost, now operation is important because it occurs throughout the entire useful life of the equipment. So definitely something to look at. But I can tell you it's a little complicated to do comparisons for operation costs. It's feasible, but there's several factors to evaluate. So we'll talk more about that here. The good news with steam is not steam but dry heat is that it only requires electricity. It requires a lot of electricity, but it only requires that. In general, you may need a little bit of compressed air, or in general, the main utility is electricity, whereas the steam sterilizer will also require electricity, but much less. You need electricity for the vacuum pump, maybe, and the control, but other than that, it doesn't need as much electricity as a dry heat. But it does require cold water for cooling the condensate, and it, of course, requires steam. Now, the steam you can get away with because steam autoclaves can always be provided with electric steam generators, which will then eliminate the need to feed some steam to the sterilizer. But if you do that, then of course you'll have to provide more electricity for that steam generator, and you'll have to feed that generator with a hot water supply. So all in all, if you look at the operation costs, one might think that a dry heat sterilizer should be less expensive to operate. Well, the answer is yes and no. It depends a lot on the cost of electricity. If you live in an area where the cost of electricity is very low, like in Quebec as an example, or I have an example here in the States where if you go to Nevada, you can buy electricity for 3 cents per kilowatt, whereas the same electricity in Hawaii is 22 cents. So it's like 7 times more, all right? So depending on the cost of electricity, it may very well happen that a dry heat sterilizer, again, comparing same chamber size, could even cost more in terms of operating costs than the steam sterilizer, despite the fact that the steam sterilizer will need steam and water and some electricity. The evaluations we did as a supplier is that I would say the cutoff line is around 15 cents per kilowatt. If the electricity is below 15 cents, a dry heat sterilizer, same size as a steam sterilizer, will cost a little bit less to operate. And if the electricity is above 15 cents, then it will be the other way around. Now, this depends a lot also on other factors, other parameters like what cycle is being used, what load items are being used, and so on. So it's very difficult to make a good side-by-side comparison. It's feasible, but you need to look at several factors. Now, if we look at the maintenance, which is also part of the ongoing cost for that kind of equipment, in theory, at least, we don't really have any hard data on that, but because it is simpler, a dry heat sterilizer should require less maintenance than the steam autoclave. Why? Because it doesn't have a pressure vessel. It doesn't have so many utilities. It's easier to access because it's not mounted in a deep pit, and so on. There's less moving parts in general. So that's one thing to look at. The only watch out again is we're comparing here same size. Okay, and we'll see in a minute here if it's a fair comparison or not. Because as we start looking at the footprint, then we say, okay, if we are comparing same size, same chamber size, the two pieces of equipment will use very similar footprint. There's not going to be any major drastic difference between those two pieces of equipment. But the difference may occur if you need more or bigger chamber to accommodate their productivity requirements. Remember that what we said earlier about the cycle time. It is possible that a larger chamber might be required to match the productivity of a steam sterilizer. If that happens, then the footprint will become larger with a dry heat, or you may end up in a situation where you need two dry heat sterilizers to match the productivity of a steam sterilizer. So in that case, you would need significantly larger footprint than the steam unit. Looking at the footprint again, one factor to look at is the capability of the equipment to process different various things together in the same load, which is something that a steam autoclave can do. It has the capability of processing different items all together, which may eliminate then the need for having multiple pieces of equipment. So if you can do everything with one piece of equipment as opposed to two or three, because of its capabilities, then you save a lot on the floor space, and the floor space can be very expensive, as you probably know. The other aspect of productivity is the turnaround time. The turnaround time is how long it takes for processing an item. In other words, how long will it take before you send a component for sterilization and how quickly it's going to come back. That's what we call the turnaround time. Clearly, because the cycle time itself is much shorter, the steam sterilizer will offer a significantly higher or quicker turnaround time. Because loading and unloading the pieces of equipment, it will be about the same. There's not going to be any major difference between loading and unloading a steam unit versus a dry heat unit. There will be that part will be about the same. The difference will be in the cycle time itself. Versatility, this is a bit redundant with what I mentioned earlier, but the steam autoclave have the more, I would say, capabilities in terms of processing a wide range of stuff, and that includes liquids, whereas the dry heat is definitely a bit more limited when we look at versatility or flexibility. Another thing to mention about steam sterilization is the availability of many different cycle or optional cycles for processing different kinds of products. I mentioned earlier terminal sterilization. That's a very specific cycle that can be used for sealed vials. Also available are cycles that combine steam and compressed air to process liquid-filled containers. Also, some cycles can use like a cold water shower. We call this a rain process to accelerate cycle or cooling down load items, things of that nature. So very many different optional cycles for many different applications. It's also possible to run decontamination cycles for waste products or like waste bags before disposal. So there's quite a bit of versatility there. I mean, most suppliers other places can offer those variants, those various cycles, depending on your very specific needs. So compatibility of material, I think that's what I said earlier, is probably the primary, the first consideration, the first thing to look at is the material able to withstand the temperature and the other conditions like humidity or moist and pressure and so on. So one thing to be careful about with dry heat is the temperature, 300 degrees Fahrenheit or 150 degrees C. There are items, obviously, that cannot withstand such a high temperature, including some plastics like polysulfones, and not all of them can withstand such high temperature. So you may need to adjust your temperature to accommodate those materials, which will then result into longer cycle time. So if the material can withstand the humidity, the pressure, the vacuum, the steam temperature is lower, 121 degrees C or lower, and that most materials can be sterilized at that temperature. And if not, then the temperature can be lowered. But if it is lowered, then remember the cycle time will be extended. The last consideration is around ergonomy and safety. To be honest, there's really no major difference there between the two pieces of equipment. Okay, most steam sterilizers are equipped with automatic doors, which from an ergonomy standpoint might be considered as an advantage versus dry hinge door for dry heat sterilizers. But it's, in my opinion, a relatively minor thing to look at. Other than that, from a safety standpoint, there are not so many differences between the two processes. So, in short, when you're considering a sterilization method, there are a few things you need to look at. Okay, first of all, are the items to be sterilized capable of withstanding the operation parameters of the method you plan on using? That's the first thing to look at. You also need to make sure that whatever method you're going to use, it's going to optimize the use of the space that you have. Okay, keeping in mind that the dry heat sterilizer will take a bit more time, or actually significantly more time than a steam sterilizer. So one has to keep that in mind, and also look at the flexibility. Which method will provide you the flexibility that you need for your application? If you have a single product or a single component that you need to sterilize, it's simple, and you don't need flexibility, then maybe you don't need a steam autoclave. But again, you have to look at the other parameters. And finally, you need to look at a method that will really optimize your productivity, maximize your productivity. Make sure that whatever you choose will be able to process all your workload in the time frame that you need. And lastly, look at the total cost of ownerships, not just the acquisition cost, but look at the other components of the total cost of ownership, the installation, the operation, the maintenance, and so on. So, all right. So that's about it. These are this is the content I had prepared for you. I could take a few minutes now. If you have questions, just let me know.
Sure, if I can jump in here, Marcel. First off, thank you very much for your presentation. It was most informative, and I'm sure everyone got a lot out of it. We do have a question, if I could read it to you. It is, given the complex variety of uses and applications, what is the best way for a client or consultant team to explore the optional technology and sterilization systems?
Right. Well, that's a very good question. You know, it reminds me of a question. We have similar questions for our washing systems as well. You know, when we're talking about temperature and chemicals and so on. So there's not so many tricks. I mean, there's any doubt around the compatibility of an items with a process. It's to look at the cut sheets or the information you can get from the suppliers of that component, and verify if it will be able to withstand the parameters that it's going to be exposed to. I mean, there are things that, okay, a stainless component, everybody knows it will be able to withstand either conditions. But when you get into the plastic components, that's where it gets a little more tricky, and that's where there's no real other solutions other than reaching out to your suppliers and finding out about the operating conditions or the operating parameters for all those components.
Okay, great. That's all the questions we have right now, Marcel. I think everyone can see your email address on the screen. If anyone does have any additional questions or they want to ask privately, please reach out to Marcel. Marcel, on behalf of SLCan, thank you very much for your presentation.
It was a pleasure, and I thank everybody. Thanks everybody for your participation. And again, as you said, feel free. My address is right at marcel_dion@steris.com. And I'll be glad to answer any questions you may have.
Great. Thanks so much, Marcel.
Very good. Have a nice day.
You too. Bye now.
All right. Bye-bye.